Hello guys, so today we are going to see the Leetcode POD, and the problem statement is like we have to find out the minimum number of increments to make the array unique. So the problem statement says that each and every element in the array should be unique. So how we can do that if we are having some sorted element, a sorted array, then how we will go, like if the previous element is less than the current element, then it will definitely be the unique till the current element. So if we sort that element, sort the array, and we check how much the current element is differing from the previous, and that much is incremented inside that array, then we can get unique elements in the array. And this is the possible way to solve this problem. So let me solve, and we will go with the sorting. So arrays dot sort nums. We will start from index 1 because index 0 element will be unique and that should not be considered. And yeah, whenever we will encounter the condition where the nums of I is less than or equal to nums of I minus 1, means it is not unique, or it get lesser than the previous element, then we have to increment it. So we will increment it by how much? So it should be incremented by the previous element plus 1, and whatever the difference of the current element. So the minimum number of moves will be nums of I minus 1 plus 1 minus nums of I, and nums of I is equal to nums of I minus 1 plus 1. We should return the minimum number of moves, and the number of, here I have to declare minimum number of moves is equal to 0. Initially it is 0, so let me check uh, what is the, yeah, so our intuition is working properly, and this solution is having time complexity of n log n, because we are sorting the nums array, and this sorting is taking n log n time complexity. By the way, this for loop is taking big O of n time complexity, but the all over time complexity is going to be n log n, because n log n time complexity is more than big O of n. So let me submit it. Okay, so it got accepted, and we should think for the time complexity where we can reduce the time complexity. Okay, so if we how we can approach that solution? So if we keep the frequency of each and every element, then we will check whether the frequency of the current element is greater than 1 or not. If it is so, means duplicates are there, then we have to move the duplicates to the next element. And whenever we getting the next the current element frequency is more than 1, then we are going to transfer that many duplicates to the next, and that's how we can solve this in big O of n time complexity, because we are just keeping the frequency only. So keeping the frequency takes the space complexity of big O of n, because we are going to take an array, but it is reducing the time complexity, so that can be beneficial. So we are going to how much the size should be for the frequency element, as we are having the number of elements n number of elements, but the maximum elements, whatever the maximum value will be there, if let's suppose all the elements present is the maximum only, then that will be the worst uh, uh, size, and here we have to increment the size to the maximum element. So we have to get the number of what is the maximum element inside the nums. So we are going to track the maximum element, and we keep the value of frequency size as n plus max. Now we are going to feed all the elements of nums in the frequency, and now we are starting with the nums of from index 1 to frequency dot length. We will check if the current frequency is greater than 1 or not. If it is so, frequency is greater than 1, then we are going to get the duplicates of the current frequency. So frequency of I minus 1, and we are going to transfer that to the next element, means I plus 1, and I frequency of I plus 1 will be uh, will be adding the duplicates as well. Why we are adding, because we are moving all the duplicates to the next element, such that that can be recorded in the minimum number of moves. And the frequency should be 1 for the current element. Now minimum number of moves is there, and here we have to declare the max value, we have to declare the min moves. Yeah, I think all the parameters are declared, and the solution is getting here. Okay. So, okay, we have to give the index value as well. Yeah. So this is working fine, and the time complexity of this solution is big O of n only, while the space complexity is also big O of n, because we are taking an array of n time complexity, or we can say n plus max, whatever the value should be. If the n is very bigger, then max is not uh, varying too much, and it is approximately big of n only, and it is not going to be like n log n. So this time complexity is better, far better than the brute force approach which we have done previously. So let me submit and see whether it get accepted or not. Okay, so it is getting accepted, and it is beating 100%. So yeah, this was the solution and discussion for the lead code problem of today's lead code problem, and thank you.